Hey, who's ready to geek out with Jimmy Ray? Come in and join me with Networking 101. You know, just what the heck is serial communication? We hear it all the time. We see it in all our devices. Why do we use it? And what actually makes it really work? Well, in a nutshell, serial communications is just that. It's a very simple, very minimal type of communications to get data across. And it's ideal for setting up really any kind of equipment because it really doesn't require any addressing. It's just a really, tight communication between two parties. Let me show you how this kind of works. Now, when we're looking at connecting up a couple devices, let's say configure an Ethernet switch, right? We can have mixed type of devices here, so I can connect it up to my PC and configure up my switch. And that's done basically with, any of the various cables that we have out here. This cable, if you look real closely at the end, this is probably one of the more common types. This is what we call DB9 type of connector. So when people refer to DB9, that's what they're really saying. They're really saying this type of connector. Some of the newer Cisco connectors use this little small mini USB type of connector. We're using this because basically we can shrink the equipment down a lot better. But in the end, this cable and this cable, they're really the same exact thing. They just got different ends. The same stuff is going on in this cable. We're just connected a little differently. Now, when you're connecting up and talking to these devices, typically on your PC or your Mac or your Unix machine, you're going to need some type of what we call a terminal emulator, some type of software that speaks that very basic type of language. So let me show you real quick, a quick example of what that software would look like. Click over to clear screen so you can see it. This is CoolTerm, which is what I like to run on my Mac and stuff. And there are a couple things that you want to notice here. First off is our baud rate. When we're talking about baud rates on equipment must match. Now this is the key on serial communication. I really can't think of any instance where you will have something that doesn't match up. They have to be identical because they have to be able to speak. Our baud rate basically is our speed. And when we're talking about speed, what we're talking about is clock. How quickly can my clock bring that information in? So you could really say 9,600 bits per second, or what you could actually say is even 9,600 hertz. That's the best speed of that clock. Now, as you can see, we've got a little drop down, and you've got a bunch of different ranges that you can pick up in here and stuff. And a lot of folks like to use 14.4 on their equipment. For me, man, I use 9600. It's tried and true. It's going to work. And typically when I'm just transferring configuration files and just doing that stuff, it's so small and so minimal, the speed really doesn't matter too much. 9600 works actually quite well. It's guaranteed to work on nearly all our equipment out there. Our databit side of the house, our databits actually is saying really what type of format are we wanting to transfer this over. You can see there's 5, 6, 7, and 8. I very rarely ever use 5 and 6. Usually it's 7 and 8. And what that really refers to is how many bits I can transfer on the wire. 7 is what we call standard ASCII, which is from 0 to 127 bits. And then 8 is the extended ASCII, and that's from 0 to 255, so you've got a lot bigger character set out there that you can transfer around. Parity is a very rudimentary form of error checking, right? On this one we have odd and even. There's actually 4 types. There's marked and spaced as well. Odd and even is what you see the most of, and it's a very rudimentary form of error checking on your lines and stuff. I very rarely see that used. Sometimes on servers, like you've got like a rib board and you're going to connect in serial that way, you can see it sometimes set up on that. But for the most part, this is actually turned off as well. And then your stop bits are kind of cool. There's 3 different measurements here. There's 1, 1.5, and 2. What a stop bit does is that it tells the device when the traffic stream is up, right? Because what you're looking at here, real quickly, is that I'm sending a bits. In serial communication, we're sending bits like a train. It's all in a bunch of boxcars. So you have bit, 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 bit. In parallel communication, you're sending everything at once, right? You're sending this whole big packet over click on one big clock cycle, and it brings all that stuff in. So it's easy to tell when a packet ends. Now you think, well, why don't we use parallel, man? That's a lot easier and stuff. The problem with parallel is that you have a very low distance range, right? You can't transfer that much information as much. You have a lot of problems with that. Serial gives us a nice big long range, and so we tend to use that a lot more on here. But because it's in this big long stream, how does your device know when it's done transferring, right? It's just bits, right? So how does it know when one bit ends and one bit stops? Well, that's where this really cool stop bit feature comes in. Go ahead and bring that back up. Stop bits are actually telling your system where these frames end. And why that's important is because every device, even though that your bits up here agree, they say, 9600 is what my speed is, every device is going to have its own little drift, right? Your clocks will age out. They just get old, man. It's just like us, right? By the time you get old, we got to start wearing glasses and all that stuff. They'll drift a little bit. And so to compensate for that drift, what we'll do is we'll say, this is where this is going to stop at. So while our speed is going to agree, we can have some variance in how that connects up, and we're always going to know when that frame ends because we'll see a stop bit. I expect a stop bit at 1, 1.5, or 2, and boom, that's where I know where these communications actually stop. It's pretty basic stuff, right? And you can do some file transfers and stuff. Pretty rare. Oh my goodness, is it slow too. So if you ever have to do what they call an X-Kermit transfer, man alive, that takes forever. But one of the things that gets confusing when people are very first starting to learn about serial communications is a term that we call straight through and null modem. You'll find out, well, this device requires a null modem. What? Null modem? It doesn't require a modem. Null means nothing. So it doesn't, great. That's fantastic. But what they're really saying is that how it's wired up. Now, this is a pretty obviously fuzzy drawing. I apologize for that. But in the end, what we're really saying is showing you how this is wired up. In the most basic form, serial in its most basic communication has a receive side on both ends, it has a transmit side on both ends, and then it has a ground because that's just electricity 101. Check that out on networking 102 as well. A straight through cable is going from receive to receive. You see that? Transmit goes from transmit to transmit. And that's how that works. A null modem cable is simply what we call an Ethernet cable, a crossover cable. They say null modem makes you sound smart and feel really cool, but in the end, it's just a crossover cable, man. You see this? I still got my ground, connecting up to allow my electricity flow, but you'll see that on my transmit side, my transmit is wired to my receive side. And my transmit over here is wired to the receive side over there. So that's what they'll call a crossover null modem. Same thing we do on Ethernet, right? Same exact. So when you hear that, automatically think of that you need a null modem cable. Now, you can actually have a null modem cable, or I didn't tell the producer I'm going to lean out of the shot here real quick, but he'll probably compensate for it. He's a pretty freaking smart dude. Anyway, well, I had a breakout box in here somewhere, but you can actually, forget it. You can actually have what they call a breakout box, where you can connect your serial cables together, and you can kind of just wire those on the fly if you get really pretty good at doing this stuff, and it works pretty darn good. But in the end, serial communications is really all about the most basic form of communication that we have out there, and it works every time, and that's why you'll always see it still getting through. And you'll see we'll keep changing cable sizes, we'll keep advancing the technology, but the advancements is done on the ends, right? You'll see us, that's where you can tell our technology is improving. The stuff in the cable itself, dude, we've been using that since the 80s. That stuff is still there. And some of your computers don't even have serial cables and stuff as well, or even ports, so you got little USB dongles, you can plug them in. Works great. That's what I use on the Mac here for the studio, and it works pretty darn well.